Hello, and welcome to my first ever tutorial, flooding an aquarium, integrating Realflow mesh and Krakatoa using Maya and Nuke. And in this tutorial I will show you how I did this specific video. I won't do it exactly like how I did it in this video because I used Naiad and 3D Studio Max for this. But for the sake of reaching a wider audience, I will use Realflow and Maya. And it's also a lot of fun. Also, I'm keeping the particle count a little bit lower because here I simulated 4 million and that took me like 12 hours to simulate. So I'm gonna keep the resolution a little bit lower for our sim because that's definitely going to make the tutorial easier for you guys to follow. But if you want to push it that far, you can. You just have to increase the resolution and you'll find out yourself. Okay. Well, I'll show you what this tutorial consists of. First, what you need is Realflow, of course. I got one here in the background. And you need Maya with V-Ray, the Krakatoa Maya plugin, and the Realflow loader plugins, and of course Nuke for the final bit. I'll show you a little bit what the passes are. This is the original Naiad particle sim that I used for my video here. I'm gonna make something comparable to this, only a little bit less detailed. Then we're going to render those particles as particles in Krakatoa. Light them, give them a nice color like this. And then also the more traditional pass. We're gonna do the liquid that you can see here and make it mesh and make it transparent and everything. And then in the end, we're gonna composite those things together and do some grading tricks, only slight grading tricks to make it look like this. Okay. Yeah, I guess let's get started then. Okay, let's create a new project. So I'm gonna do it on my G disk Aquarium tutorial. That's where I'm gonna put it, and I'm gonna call it Aquarium Sim 1. Okay, gonna make those folder structures, create new project, nice. Okay, well, the first thing that we need in here, in this scene, is our domain. And then in here you have the resolution settings. Well, let's put this on 0.1 first, the cell size. That should be okay. Hold on. Let's make the container. Let's make cube. There we have it. And let's call the cube container. And because we want to fill the screen, and the screen is going to be 16 by 9 aspect ratio, then I'm going to give the cube dimensions that are also 16 by 9. The dimensions in Realflow by default are in meters, I think. So the box is going to be 10 meters wide. It's quite large. I'm going to make it 5.625 meters high and 1 meter deep. Move it just to the base a little bit. There we go. It's perfect. Okay. We have to put this cube on solid outside. This means that the cube will be interpreted as hollow. It means that the outside is solid, so that particles will be able to stay inside the cube but won't go outside. If you put it on the default, solid inside, yeah, then of course particles can live outside the cube but cannot enter the cube. Now we're gonna make the cube for the emitter. Make another cube, and you can name this one to emitter. Now we're also gonna increase the resolution of the emitter in the container. Lowering the value means that you're increasing the resolution. I can show you in a domain. This is the domain over here. And in the domain, if you increase the cell size, you see that these boxes over here, those are getting bigger and bigger. So the smaller the resolution of the cells, the more cells we have, so the more work the computer has to do, but also the more detail we get. So if you have a really big cell size, then the detail is going to be way lower. I'm going to put it to 0.1 for now. Okay, well, we have the two meshes here. We can disconnect the emitter because it's not needed in the scene. It's going to be referenced. Gonna check if it's on solid inside. Yes, it is. Okay, now we're gonna resize it in the size that we want. Whoop. Yeah, let's resize the box to 1.6 and 0.8 and again 0.8. And let's place it where we want it to be placed. Somewhere here. Yeah, that's about right, I think. Now let's create the emitter, the source of our particles. Oh, do it like this. And now I'm gonna assign it to the emitter that we have. Bam. Okay, as you can see in the emitter, this file, the object emitter, so this file is being referenced. Okay, and we're gonna put this to stream. That means that it's gonna be continuously flowing. And we're gonna give it some initial speed, so it will move when it's being birthed. Here we have the core particle sampling, and this basically defines how many particles per cell that Realflow will spawn, and it's basically 2 to the power of 3 here. It says 2, so that's 2 times 2 times 2, which means 8 particles will be spawned on each cell. If you increase this, of course, this will get really heavy really fast. So for now, we'll leave it at 2. So now let's see what we get here. Okay. Gonna hit simulate and see what happens. It's already quite heavy. Maybe a little bit too heavy. Okay, that was getting way too heavy, so let's decrease the cell size. Okay, sorry for the jump. Let's try it with this resolution. Here we go, there it comes. Ah yes, here you see it's slowing down way too fast, feel way too early. We can fix this. In a container, you have a surface offset. At the moment, the surface for the particles is over here, rounded off. Let's move it over to the actual edge of the mesh. Do it by adding a surface offset of minus 0.1. Let's try again. It's better, but not amazing yet. Let's decrease the amount of particles that you can spawn from here and get the cell size back to the original. Now it should be much better. Let us watch. Yes, now it's overshooting a little bit, but that's much better than what we had before. Let's just keep it at this, I guess. Yeah, that's perfect. Well, perfect. That's good enough. Okay, well, what we need in this scene now is some gravity. And we need to move this emitter, rotate it a little bit so it points that way. We want it to hit this wall and then bounce off like that. Let's see if it works. Yes, it does. It's still a little bit weak, so let's increase the initial speed to 5. Yeah, I like that. Now, and to add some variation to the whole simulation, I'm going to add some noise over this. So let's look at the noise field. Okay, well, let's get a look at the noise field. Here it is. Okay, we want to have it affect just the region, so we put it bounded to yes. So this means that the noise will be affecting everything inside the sphere. Okay, there we go. Oh. And yeah, let's put the force on the effect type on velocity and the strength on 50. Okay, let's see what happens when I sim now. It's a bit more interesting. Yeah, that's definitely better. Now let's put a key on the emitter over here. Stream. Okay. We're gonna want to make the emitter emit up to frame 80. So on frame 80 we're gonna put a key, add key, and then one frame ahead, put another key. Oh shit, here's put it on no, add key. Now let's check out the curve. Okay. That, I guess that works. Let's check it out. Yes, it works. Now what will happen, it will start emitting from frame 0 up to frame 80 and then it will stop. Afterwards we will just let the fluid settle over here. Let's also change our frame range here. 375 is I think 15 seconds. Also, before I forget, we have to set everything up. FPS output is 25, so that will definitely change the way that our sim will look. Max substeps, min substeps, that's, yeah, I think that's pretty good. Good enough for what we're doing at the moment. And if you want to, you can use your GPU for simulation over here. Just add this, but I won't because my GPU is shit. Well, oh yeah. Let's test this. Okay, this is taking way too long to test out, so I'm gonna use the command line to test out the sim because that's way quicker. I'll show you over here. Bam. Simming like this will save you a lot of time because the whole graphical interface and everything doesn't have to be updated every frame. So it's just pure simming and it's wonderful, I tell you. Okay, it reached frame 80. That's where we set our keyframe. So let me check what it looks like. I'm just closing the simulation thing. Then you have to press this button to update the particle caches in the timeline. And we have a lot more from a previous sim than just 80. But let's see. Yeah, up to 80 it looks fine. I'm not gonna overfill the box and it just stops nicely. It's perfect. You can just ignore this thing. This was an error I had before. Looks freaky, right? Oh well. Okay. Well, I guess now it's time to increase the resolution of our simulation in such a way that we have way more detail, small detail and particles. We're going to do this by increasing the resolution, so decreasing the cell size to 0.08, that should be fine, and increasing the core particle sampling to 6. Now, for the whole sim, we're probably going to get like over 1 million. Not a lot over 1 million, but that's quite a lot of particles. And we're going to do the final sim. For the final sim, what you have to do in Export Central is enable PRT saving. PRT files are Krakatoa specific particle files, and they're quite cool. There's some nice compression on there, and Krakatoa works really nicely with them, really quickly. And so yeah, you you would prefer those over the standard Realflow bin files. So you open the Export Central, go to your domain, Hybrido domain, checkbox on the Hybrido domain, particle cache, this is normal Realflow stuff. Here, particle Krakatoa, you can disable displacement texture, we do not need this. Particle Krakatoa, enable this, and we can select the channels that we need. We don't need radius, we don't need normals, no vorticity, and no texture. Just position, velocity, those are the most important ones. Those are the only ones we're going to use in this tutorial. But ID is usually very useful, so I usually enable this just in case. Okay, there we go. And I'm gonna reset this. And now I'm gonna simulate the whole thing for you. I'm gonna move on to another simulation that I already did, so the nodes are gonna change a little bit and the file name is gonna change, but this just to save time for myself. Okay, well, let's start the command line simulation. Okay, so this is the simulation that I did earlier. Took me like 1 hour and 5 minutes to simulate everything on an Intel i7 processor overclocked to 4.5 gigahertz. So on a really slow machine, it should take like maybe 3 hours, so it's not that bad. Yeah, of course, hit the update button to update to the latest cache. Let's view it. Um, looks interesting. That's pretty cool. Well, if you want to, you can preview this, just make a preview animation. But for now, we're gonna go straight to the meshing of the thing. Okay. Okay, now to mesh this, we have to create a Hybrido mesh. This gets plugged in straight into the Hybrido domain. Then we're gonna disable auto polygon size, disable auto particle radius, go to filters, and disable splash thinning filter. Okay, and for the sake of this tutorial, we're gonna do it visually. So reset, I always reset, load the particles, and now, yes, now it's meshing. You can double check. It's if you go to the folder that you created for Realflow. This is a different folder, of course, because it's a different project, but it's building the meshes. Now let's skip ahead to where I built all the meshes. This is also going to take quite a long time. This is probably going to take more time than a sim. Mine took 1.5 hours to finish. Okay, so here we have the finished meshes. And what we need to do is we need to convert these Realflow bin meshes to V-Ray meshes. And this way we can actually render the motion vectors that these meshes carry. The Realflow bin meshes do not really uh, work well with Maya V-Ray. So that's why I have to convert it to a V-Ray file. And you do this by going to your Start menu, and then finding your Chaos Group folder, going to your Maya V-Ray, Tools, and Apply to VRR Mesh Converter. Okay, this opens up a command prompt, and over here, what you have to do is you have to get the location of these files. I'm just gonna copy this full name and add a backslash. Do it like this. I'm just gonna type here because it's easier. Add a star. So remove the frame numbering and add just replace it by a star. I'm gonna copy this. If you hit enter now, it's gonna freak out. Just click back. Here, type apply to VR mesh space parentheses quotation mark, sorry, paste, and another quotation mark, and hit enter. Okay, now it's running and converting these files. Ah, there it is. See? It's quite quick. This will only take a few minutes. Well, and all you have to do is wait for this to finish, and then we can move on to the other part of the tutorial, and that's the Maya part. And in this, we're gonna build the shader in V-Ray, make it work in Krakatoa, and render everything. Well, thanks for watching this part of the tutorial. See you in the next one.